Bismillahirrahmanirrahim. Assalamu alaikum students. Today's lecture is about the periodic table and periodicity of properties. It is the second lecture. What is the periodicity of the properties? Periodicity is the properties you have already learned that properties of the elements repeated after the intervals. So they show show a repeated manner or they repeat in specific intervals. It is the periodicity. So chemical properties depends on the valence shell electronic configuration. Because all the elements of the particular group have the similar valence shell electronic configuration, they possess the similar chemical characters. So why the chemical properties in a group are the same? Elements that are present in a particular group, they show the similar chemical properties because they have the similar valence shell electronic configuration. In their valence shell, the number of electrons are similar, so elements present in a particular group, they show the similar chemical properties. And as the physical properties depends on the size of the atom, and you know that size of the atom change gradually from top to bottom in a group, so the elements show the gradation in the physical properties in the same group. So chemical properties depending on the number of valence electrons, so they will have the similar chemical properties because they have the similar valence shell electronic configuration. But in the group physical properties, they will be different. The reason is that because physical properties, they depend on the size of the atom, and size of the atom change from top to bottom when we are moving in a group, so they show the difference in their physical properties. First property we will learn about, that is the shielding effect. And what is this shielding effect? Shielding effect is actually the reduction in force of attraction between the nucleus and the valence electron. And why this force of attraction between the nucleus and valence electron reduce or decreases? It is due to the presence of electrons in the inner subshell. So due to the presence of these inner subshells, the force of attraction between the nucleus and the valence electron decreases. It is called the shielding effect. As electrons present in the inner shell cut off the attractive force between the nucleus and the valence electrons. Here you can see the structure of this lithium, beryllium and magnesium. So you can see that lithium has the 3 number of electrons and consisting of the 2 shells. In case of the beryllium, 4 electrons are present. Again they are present in 2 shells. But in case of the magnesium, you can see that 12 electrons are present in 3 shells. So when we move from lithium towards the magnesium, size of the atom is increasing. So you can see here are the 2 shells, while here there are the 3 shells. So when we move from top to bottom in a group, from just like in the lithium towards the magnesium, it is the same group. When you move from top to bottom in a group, the number of electronic shell increases. As you have seen here, lithium has the 2 shells while magnesium has the 3 shells. So the number of electronic shells are increasing, so the number of electrons in the inner shell also increasing, and as a result this shielding effect increases. But what happens when we move from left to right in a period? The number of electrons in the inner shell remain constant, just like you can see when we move from lithium towards the beryllium. Here you can see that here are the 2 shells and again in the beryllium there are the 2 shells. So the number of electrons in the inner shell remain the constant. Here the inner shell is this, containing the 2 electrons. Again in the beryllium, inner shell containing the 2 electrons. So number of electrons in the inner shells, they remain the same. That is why the shielding effect remain the constant when we move from left to right in a period. From top to bottom in a group, shielding effect increases, and from left to right in a period, shielding effect remain constant. Next property is the atomic size. And what is this atomic size? The size of an atom is the average distance between the nucleus of an atom and the outer electronic shell. Means the distance between the nucleus and the valence shell is considered as the size of the atom. Here you can see that when you are moving in a period from this lithium towards the beryllium, then boron, carbon, nitrogen, you can see the size is going on decreasing. And what is the reason for that? When atomic radius decreases in any given period, as you move across the period, the reason is when you move from one element to the next on its right in a period, another electron is added. In the lithium, atomic number is the 2, beryllium atomic number is 3, boron atomic number is lithium atomic number is 3, beryllium atomic number is 4, boron has the atomic number 5, carbon has the atomic number 6. So you can see that along the period atomic number is increasing. As the atomic number is increasing, it means the number of electron and the number of proton are also increasing. So when the number of electrons and number of protons are also increasing, the attractive force of the nucleus and the valence electron also increases, because there are no progressive shells are added here. It is the period, these are the elements of the period number 2. Period number 2 means all these elements have the 2 shells. They consist of only 2 shells, but their number of electrons and protons are increasing when you are moving towards the right side. So when we are moving in a period, the atomic radius decreases because the attractive force of the nucleus and valence electron is increasing due to the increase in the number of electrons and protons in the same shells. So that is the reason you can say that the effective nuclear charge is increasing. Effective nuclear charge is the number of the protons present in the atom. So when we are moving from left to right in a period, number of protons are increasing, number of electrons are increasing, but number of shells remain the same. Only you can see that lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, all they exist in the period number 2, means they have only 2 shells, but they have the but the number of electrons and protons is increasing. So when the number of electron and proton is increasing, the force of attraction between the nucleus and the electron is also increasing. Positive charge is increasing as well as the number of electron are increasing. So greater force of attraction between the nucleus and the electrons exist here when we are moving along the period. That is the reason, due to the increase in this force of attraction, the atomic size decreases along a period. You can see that the size is shrinking. Size of the atom is decreasing. This is due to the effective nuclear charge. This is due to the increased force of attraction between the electrons and protons. So the atomic radius increases in any given main group as you move down the group. Here you can see that the two groups are given, first A and second A, from hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. You can see the size of atom is increasing gradually. Why this size of atom is increasing? As you move from one to the next element in the group, what happen? Additional shells are added here. You can see that hydrogen in the first period containing the one shell, lithium present in the second period containing the 2 shells. Next is the sodium containing the 3 shells, potassium containing the 4 shells. So number of shells are increasing. It means the size of atom is increasing by the addition of these shells. So when we are moving in a group, so what is this ionization energy? Ionization energy is the minimum amount of energy required to remove the outermost electron from an isolated gaseous atom. In this image you can see that the element an element containing the 4 protons as well as it is containing the 4 electron. So what is this ionization energy? When we want to remove this electron from the valence shell, the electron is going to remove from this valence shell, and for this purpose amount of energy is required to remove this electron. So this minimum amount of energy that is required to remove this electron from this valence shell and form an isolated gaseous atom, this energy is called the ionization energy. And you can see that ionization energy explains the formation of the cations. As in this picture you can see that electron is removed, and when electron is removed, remaining electrons are the 3 and there are the 4 protons. So positive charge is increased. It explains the formation of the cation. So ionization energy explains the formation of the cation. And what is the importance of this ionization energy? You can find here that ionization energy is a measure of the extent to which the nucleus attracts the outermost electron. Obviously this is the energy you are going to you are needed to remove the electron from the valence shell. Higher ionization energy means you have to put more energy to put off the electron from this. So high value of ionization energy means strong attraction between the nucleus and the outermost electron, and when this ionization value is lower, it means the force of attraction between the nucleus and the electron is weaker. So low ionization energy indicate the weak force of attraction between the nucleus and the electron, and higher ionization energy value shows that the force of attraction between the nucleus and the electrons is very high. So what is the periodic trend of this ionization energy? Ionization energy value decreases from top to bottom in a group. Here you can see that ionization energy in a group is decreasing. So hydrogen has the maximum ionization energy. Next is the lithium, having less energy than hydrogen, then sodium having the less energy than this lithium. In this way ionization energy value is decreasing from top to bottom in a group. Now what is the reason for the decrease in this ionization energy? This is because the shielding effect in the atom increases as you descend. Means when you are moving down the group, descending, you are descending down the group, what happens? Shielding effect increases. And why this shielding effect increases? Because size of atom is increasing. In each case one more shell is added, so size of atom is increasing. Greater shielding effect result in weaker force of attraction between the nucleus and the valence electron. So they can easily be removed when there will be less force of attraction between the nucleus and the valence electron. So when there will be less force of attraction, the ionization energy will also be less. Easily electron can be pulled out from the valence shell. So what happened when we are moving in a period from left to right? Here I have given the example of this second period. You can see that ionization energy value is increasing. So why this ionization energy value increasing when we are moving in a period? So what happened, as I have told that shielding effect remain the constant along the period, but effective nuclear charge is increasing. Why this nuclear charge is increasing? Because the number of electron and proton are increasing. Number of shell remain the same, but number of electron and proton is increasing. When the number of electron and proton will increasing, there will be greater force of attraction between the nucleus and the valence electron. So that's why an increase in ionization energy take place from left to right in a period. Next property is electron affinity. And what is this electron affinity? Electron affinity is defined as the amount of energy released when an electron add up in the valence shell of an isolated atom to form a uni-negative gaseous sign. In this picture you can see that it's the valence shell of the chlorine, and one electron is going to be added in this valence shell. So when we are going to add an electron in the valence shell of an atom, amount of energy is released, and this released amount of energy is called the electron affinity. And electron affinity explains the anion formation. As you have seen that when we will introduce an electron in the shell, number of electron will increase from the number of the proton. As a result, anion will be formed. What is the periodic trend of this? As you move from left to right across a period, electron affinity generally increases. And what is the reason? Again, the reason is same as the ionization potential or ionization energy. And this is due to the increase in nuclear charge, effective nuclear charge. And when effective nuclear charge increases, this will decrease the atomic radius, size of atom is shrink, and this binds the extra electron more tightly to the nucleus. As size of atom decreases along the period, force of attraction between the nucleus and valence electron increases. As a result, extra electron more tightly bound to the nucleus. So electron affinity value increases when we move across a period. And what happens when we move from top to bottom in a group? Electron affinity value decreases. And why this decreases? Due to the increase in the shielding effect. Due to this shielding effect, the force of attraction between the nucleus and valence electron decreases, and as a result, electron affinity value decreases along a group. Now here the comparison of the ionization potential or ionization energy with the electron affinity. So in ionization energy is absorbed during this process, but electron affinity, as you have seen that we introduce the electron during this process, energy is released. Ionization energy is an endothermic process because energy is absorbed during this process. When you are going to pull out the electron, energy is provided to the system, so it is an endothermic process. And electron affinity, this process is the exothermic because energy is released during this process. Ionization energy explains the formation of the cation, and electron affinity explains the formation of the anions. Here a brief briefing of this different values of these characters. Just like the ionization energy is increasing along the period, as well as electron affinity is also increasing along the period. Atomic radius increases along a group, and decreases along the period. So atomic radius, you can see it is decreasing along a period. When you are moving from right to left, it will decrease, and it will increase when you will move from top to bottom. Electron affinity values will increase when we move from left to right in a period, and it will decrease when we move down the group. And again, you can see the arrow sign here. The electron affinity and ionization energy value increases when you moving from down to the upside in a group. So these are the short you can say here the shorthand or simple briefing of the values of ionization energy, electron affinity or the atomic radius.